Hello, hello. Yes, we welcome you back to this channel, PSSB, Physical Sciences Silver Bullet, and it's me, Richard. Today we are looking at this question. It says, a learner designed an experiment for electroplating of necklace with chromium using chromium as the electrolyte. Then comes the question 4.5, says, during electroplating, the necklace gained a mass of 0.84 grams of chromium. And we say, calculate the number of moles of electron transferred during the process. How do we go about this? Okay, what we do, we need to have the knowledge of the equation. Okay, what happens at the necklace? Chromium ions are being reduced to chromium metal. Let us look at that Hertz reaction. Okay, that is the Hertz reaction. Now, I want you to take note of this. Okay, those are 3 moles. So what does this mean? That 3 moles of electrons liberate 1 mole of chromium metal. Let us put that one in writing. Okay, so 3 moles of electron produce 1 mole of chromium. We have to remember that we are given our chromium in mass, in grams. So now you have to know that 1 mole of chromium is equal to molar mass of chromium. So you can write this statement and say 3 moles of electrons produce the molar mass of chromium, which is 52 grams. So let us put it down. So that's the statement. Now we need to see, what do we know? Now we know the mass which was deposited on the necklace, and it is 0.84 grams. So what do? We say X moles because of electrons will produce this mass. Let us put that one in writing. So that is that. And you have to know that these are directly proportional. So having this and having that and having this and having that gives us the equation to use. So we cross multiply, and what we get, our X can be calculated. So let us do that. So that's what we get. After cross multiplying, we get the number of moles of electron as 0.0485 moles. Okay, so let us now see the next question. Okay, then comes the next question. It says calculate the number of electrons transferred during the process. I want you to look at these 2 questions. The first question wanted the number of moles of electrons. And the second question wants number of electrons. So the question is, how do we change number of moles to number of entities. The equation is clear and it's known. It says number of moles is equal to number of entities or number of particles or whatever you are dealing with over Avogadro number. Thank you. So in this case, when you substitute, we know number of electrons is 0.0485 and number of entities is what we are looking for, which is number of electrons. Then let us quote Avogadro number and we get the number of electrons which were transferred. So from here, all we need to do is to cross multiply and get the answer. Let's see what we get. So that's what we get. The number of electrons transferred is 2.92 times 10 power 22 electrons. Okay, so we go to the next question. Yeah, then comes this question, 4.53. It says, calculate the amount of current passing through the solution if the process takes 10 hours. Okay, how do we go about this? Okay, we have to remember that charge or quantity of electricity is equal to current times time. That one makes our equation 1. And you have also to remember that charge is equal to, charge is the amount of charge or quantity of electricity is equal to number of electrons times the electronic charge. That's equation number 2. So with these two equations, what do you know? We're talking about the same quantity of electricity here. So that means that we have the equation. The equation says that NE, or number of electrons times electronic charge, is equal to IT. Okay. So what is the number of electrons flowing? We have them already. And the electronic charge is a constant, which is 1.6 times 10 power minus 19. Time has been given as 10 hours. We just have to convert it to seconds. And I, or current, happens to be our only unknown. Let us substitute in and we see. So this is what we get after substitution. This is what we calculated, the number of electrons flowing through the solution, transferred. This happens to be the electronic charge, and time was given in hours, so, and we need it in seconds, so we multiplied it by 60 to convert it to minutes, and by 60 to convert it to seconds. When you look at here, I is the only unknown, and we can simply compute it out. So after substitution, this is what we get as the amount of current flowing through the solution. Okay, then comes the next question. Let us look at it. Yes, then comes this question. It says, give 3 advantages of electroplating. Okay. So what is the reason why we electroplate? To cover the material with a thin lining of the metal. Why? First, to prevent rusting. Materials which have iron, we know that iron undergo atmospheric oxidation, changing color and losing the strength. So we tend to cover such material with another metal which does not undergo rusting. So first, to prevent rusting. What is the second one? To improve the appearance of the material. We know all these gold-plated earrings, necklaces, and what have you. They look nice, so the appearance is good. And three, to prevent corrosion. Corrosion is when the material loses the outer layer gradually. And if you cover that material with a metal which is not easily corrosible, you can protect it from corrosion. So those are the three advantages. Prevent rusting, okay. 2, prevent corrosion. And 3, improve the appearance of the substance. Let us put it down. So there we are. And with that, we are going to cut this video here. We thank you for your time. We appreciate it. We don't take it for granted. And we thank you for your subscription. The channel is Physical Sciences Silver Bullet, PSSB. And it's me, Richard. Till we meet again. Bye-bye.